Let us start the lecture. In this lecture, we are going to discuss about Bohr's atomic model. First of all, we have to know the postulates of Bohr's atomic model. The first one is the central part of atom contain total positive charge and almost whole mass called nucleus. As we know, inside the atom, electron and nucleus are there. So the central part is called nucleus, in which the total positive charge of atom and 99% mass of atom is present. Okay, and this is our nucleus. Okay, then how electrons are revolving around this? In the second postulate, electrons are revolving in a fixed circular permitted orbit. Random orbit के electron माने बोलिबेनी, गोटे permitted orbit रे बोलिबे, and he named that orbit as stationary orbit. Let this is the first orbit and this is our second orbit. Some electrons are there in first orbit and some electrons are there in also second orbit, yes or no? And they are permitted to move or revolve or along these orbits only. Okay. In such orbits, electron does not radiate any energy. आमे already discussion करथिले रदरफोर्ड रो लिमिटेशन ने कहथिले जेहेतु सेठी ऑल पॉसिबल रेडर रे बोलुचंती, तेनु करी किछि एनर्जी एमिट करिवे electromagnetic radiation. So we must follow a spiral path and atom becomes unstable. To overcome this, Bohr suggested that the electrons are revolving in a fixed circular orbit, and in such orbits electron doesn't radiate any energy. Then the third one is this is actually Bohr quantization formula. Angular momentum associated with an electron while revolving in a stationary orbit is an integral multiple of h by 2 pi. We all know the formula for angular momentum. L is our mvr, yes or no? mv is a linear momentum, p, r is the radius, yes or no? And here we can write L equal to nh upon 2 pi. Okay, then just here L equal to mvr equal to nh by 2 pi. And after then the fourth one is our electrons are capable of changing their orbits. Electron can jump from lower orbit to higher orbit, or also from higher orbit to lower orbit. This is our first orbit. The energy of first orbit is E1, energy of second orbit is E2. So no, and the energy difference between two orbit E2 minus E1 equal to h nu, where h is our Planck's constant. Value of Planck's constant is 6.626 into 10 to the power minus 34 joule second. Okay, and this nu is our frequency of radiation. Then just see here, let this is our nucleus, this is the first orbit, this is the second orbit, and this is one electron in the first orbit. Let this is some energy which is given to the electron. Then just see, when energy is absorbed by the electron, electron becomes energetic and move to the upper orbit. Here we can conclude that by gaining energy, electron can jump from lower orbit to higher orbit. And then second one, let this is the electron in the second orbit, this electron is in the second orbit, yes or no? Then some energy is released, by the electron. So what happened to this? Its energy reduces and then jumps to the lower state, yes or no? This energy is our h nu. Here also is our h nu. By gaining energy, electron jumps from lower orbit to higher orbit, and by emitting energy, electron jumps from higher orbit to lower orbit, yes or no? This is all about the postulates of Bohr's atomic model.